You can write as much of this down as you want. Jimmy crack corn, I don't care.
You say that all the time.
I know, well.
Well, what the heck?
I'll tell you the really, really important part. Most of this is just sort of preliminary stuff. So, most electric charge is measured in coulombs. In a famous experiment known as the Millikan experiment, Robert Millikan discovered the charge on a single teeny tiny electron. What is that charge? Anybody remember? Minus 19. 1.6 times 10 to the minus 19 coulombs.
So what is 1 coulomb?
1 coulomb is 6.25 times 10 to the 18 electrons.
That 96 in that class?
Don't worry, I'll write those numbers down for you. This charge is known as an elementary charge. Now this, I believe, is the first time I referred to it as 1 Elch. Elch is a made-up word. I think I made it up. It stands for elementary charge. That's a lot of syllables, so I call it the Elch. And I don't want to seem...
Oh, you made it up, so...
you know what, I honestly don't know if I did or not. I've been using it so long, I don't know. He found 1 electron to have a charge of 1.6 times 10 to the minus 19 coulombs. Now you remember the whole scientific notation stuff. What does that mean? 1.6 times 10 to the minus 19, that means 0.0000000. How many zeros?
19.
Actually only 18. 1, 6. 18 zeros plus the 1. There is very few left here, but you can look. I think I see 1.
Wow.
Okay? So the reason why we use those scientific notation is because writing out .00000000000000000000016 is hard to do, plus when you write it out, guess who has to count them all to make sure it's right. So we're going to write that as 1.6 times 10 to the minus 19 coulombs. You'll remember I showed you how to do it on your calculator, right? EXP or EE on your calculator, right? So, Millikan found out that when tiny oil droplets were subjected to X-rays, they become ionized. What does that mean, to become ionized? Charged. An ion, you might remember from chemistry, when something like, say, a fluorine atom over there on the right, when a fluorine atom gains 1 electron, it's known as a fluorine ion. An ion, right? You gotta watch out for them. Anyways, back to...
That's the reaction.
Somebody get that guy a Kleenex. Anyways, so Millikan discovered that when the tiny oil droplets were subjected to X-rays, they became ionized. And thus charged, right? Okay. Some of the charges would be -1, -2, -3, -4, and so on, right? -1, -2, extra electrons. When you gain electrons, you become negative. When you get rid of electrons, you become positive.
It's like death.
It's like debt. He thought that if he could measure the total charge of a drop, it would be a small multiple of the fundamental element charge. So he tried to figure out what the charges were on these oil droplets, and then given that, he would say that that is a multiple of the fundamental charge. A multiple you guys like to explain multiples, right? Like multiples of like 5 would be like 5, 10, 15, 20, right? So he discovered these numbers, lightly made a graph, found the slope, got the elementary charge. His apparatus looked like this. You already know this, right? Sprayed the oil droplets in here, they fell through, blah, blah, blah. X-rays, right? Down here you got gravity, weight force, and you've got now, because this is charged, right? Positive charge, negative charge, right? So the negatives, the negatives are going to push up, and when these forces are balanced, when the FE and the FW are balanced, just like when the applied force and the friction force are balanced, you get what kind of acceleration? Zero. Net force is zero, and the object will either fall at a constant rate, or if you manage to increase the FE a little bit and then balance it off that way, you can actually get it to hover, which is what he did do. Blah, blah.
What's the atomizer?
The atomizer is just a spray bottle that sprays oil into it. It's a fancy word for spray bottle, which is the universal symbol like this.
Is that not
Just think of that. That's talking?
Yeah, that's talking.
That I know. That I know. Millikan sprayed oil onto the top of the top plate. Some of the oil fell through the hole. When the droplets were inside the two plates, they experienced two forces: gravity and electric field force. That's what I just said. The force due to gravity can be calculated with Fw equals mg. Some people say when the droplets are sprayed, they receive a negative charge due to the plastic nozzle. Most booklets say, and I got to fix this, that he used X-rays. It really doesn't matter how you guys, right? When inside the two plates, they experience an upward repulsive force. This force depends upon the strength of the electric field. Why? Because E is equal to Fe over Q. And so if you've got a bigger E value, then you get a bigger electric force, right? So as he increases the electric field, the electric force also increased. Okay, we're doing good. He noticed that the drops were slowing down, stopped, moving up, depending on the strength of the electric field, which he could control. And these behaviors seem to depend upon the mass of the oil droplet. The greater the mass, the greater the gravitational pull down, right? The charge on the oil. The greater the electric charge, the more force there is up. And the electric field strength, which he could control with a knobby thing. Now, I'm going to go out and I'm going to lie a little bit. He actually measured the terminal velocity, and there is also some, what's the word I'm looking for? Controversy, that's the word I'm trying to come up with. Controversy about the viscosity of oil and the terminal velocity. The viscosity of oil refers to, any of you guys, automotive guys, know what does viscosity mean, Brett? Yeah, how thick it is, right? Like a milkshake would have a really high viscosity. Water is really low. So it's a measure of how much it flows. Is that opposite? Okay, I always get back. Anyway, I'm going to get around all that because it's complicated math, and we're going to use, because you guys are familiar with it, we're going to use good old density. Remember the formula for density? Right from like the first 2 or 3 weeks? D equals M over V. Density equals mass over volume. We're going to use that. He used this to determine their mass and then their weight in newtons. Don't worry, I'm going to do example questions with you. Since he could adjust the electric field strength, cause the vector to change, the E was actually a measure of the charge on the drops. Using this information, blah, 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 he could calculate the drops charges and found the charge was never less than a certain value. It always had some sort of bottom value. And all of the charges were a multiple of this minimum charge. So let's say that this charge was 3, then the multiples were 3, 6, 9, 12, and so on. By looking at this, he would determine that the elementary charge in this case is 3. Remember, it's not 3, what is it?
1.6.
1.6 times 10 to the minus 19. A whole lot harder number. He concluded that the minimum charge was 1.602, or 1.6 times 10 to the minus 19 coulombs. Okay? I think he actually came up with 1.59, didn't he? Yeah. This means that a proton has a charge of what? 1? What did you say, AJ?
Positive 1.
Yeah, exactly. Kind of backwards, eh? I'm supposed to do the drum roll before you say. Plus 1.602 times 10 to the minus 19. Protons and electrons have exactly the same charge. Electrons are negative, protons are positive, right? Exactly the same. Okay, you should write this down. This is the conversion from Elches to coulombs. This is the conversion from Elches to coulombs. So I'll let you jot that down while I do attendance, and then I'll be right back. Alright, so we have determined, with the help of Millikan, that one elementary charge is 1.602 times 10 to the minus 19 coulombs. How many electrons, and this is the question Ty asked about 6 minutes ago, not in these exact words, but more or less, how many electrons are required to have 1 coulomb of charge? How many individual electrons do I need to add up to 1 whole coulomb of charge? How are we going to do this?
1.602.
What? No, it's 0.00.
One electron has 1.602 times 10 to the minus 19. Like, so for example, let's just say that 1 Elch was equal to 0.25 coulombs. I'm going to need 4 Elches, right, to get to 1 coulomb.
Oh, yeah.
Right? How'd you get 4? Well, you just know, 0.25, 0.25, right? Well, what if you take 1, divide by 0.25, what do you get? So instead of going 1 divided by 0.25, we're going to go 1 divided by 1.602 times 10 to the minus 19. You can set it up as a ratio or proportion if you want, which is what you learned in junior high. I know you did.
Is that all the Gaussian numbers?
I did not learn that.
No, that is 6.02 times 10 to the 23, and how do I still remember that? I had an unlimited supply of useless information in my head, Brad. You would say that 1 elementary charge is equivalent to 1.602 times 10 to the minus 19. So X elementary charges, notice that the Elches are both on the top, is equivalent to 1 coulomb. Why 1 coulomb? Because that's what it said. How many electrons? I'm looking for how many Elches in a coulomb. How do you solve a system like that? Cross multiply. So you're going to have 1 times 1, which is 1. 1.602 times 10 to the minus 19 times x is just going to give you 1.602 times 10 to the minus 19. X is equal to 1, and now you divide by that, and you get, there's the number, 6.25 times 10 to the 18 Elches. It's just the inverse, that's all it is. So you need 625 Brazilian electrons.
Why can't you
Do you know? Okay, you're probably thinking right now, gee, I sure hope he does some Millikan sample questions. Alright, so I have provided you with some sample questions. I'm going to remind you that in about 20 minutes you're going to practice some of them. So think of what I'm about to do as pre-helping. I'm showing you how to do it before you realize you need the help, right? Here's where you learn how to do it. Just a gentle reminder. Alright, so, and as always, these are sort of scaled in degree of difficulty, starting with the easiest. Okay? So, sample number 1. A small ball of mass, 6.5 times 10 to the minus 6 kilograms, has a charge of 1.5 times 10 to the minus 10 coulombs. It's suspended in air above an electrically charged plate. What field strength is required to suspend this particle in the air? So what field strength we are solving for the? E. We're solving for E. I'm going to run this chair right now. E equals what's up? Fe over Q, you're right. Do we have Fe?
Yeah.
Fe stands for electric force. We don't have the Fe. Let's draw a picture. We've got a small ball, and its gravity is pulling it down, and the electric force is pushing it up, right? And the key word in the problem is suspended. Now that might bring back some bad memories for you, I don't know. But in this case it means what? Just means that it's hanging there. And the forces are equal. The forces are equal. Can we find the weight force? Yeah, as long as you got the mass, you can always find the weight force. So Fw is equal to mg. Mass, 6.5 times 10 to the minus 6. Gravity, minus 9.8. And I wish I had my calculator back, but AJ has it. I have another one, but I think the battery's dead. .37 times 10 to the minus 5. You have to write the times 10 to the minus 5. I've seen a few people not do that. You have to do that. But you don't have to type it in your calculator. You go 6.5 exp minus 6 times minus 9.8. Okay, so that's the weight force. Now that's actually negative because it's down, which means that the Fe is actually up positive 6.37 times 10 to the minus 5, right? Okay, so that's what you're going to plug into. E equals F over Q.
Oh, we don't have charges. So now we do E equals
Q is charge. So the Fe here is 6.37 times 10 to the minus 5. Now the charge has to be in coulombs. Okay? Charge has to be in coulombs. So 1.5 times 10 to the minus 10. Now I'm going to stop there and I'm going to encourage you to try that on your own calculator because it's important that you can do that actual division with scientific notation. So I will give you a moment to try that. Usually 2 decimal places after the decimal is good, like two digits. So you should get 4.25 times 10 times 10 to the 5 newtons per kilo. So you're going to go on your calculator. You're going to go 6.37 exp negative 5 divide by 1.5 exp negative 10 equals. You got to hit equals.
I got that shit over here.
Okay, let's try. That's the simplest kind of question. 1, 2 marks. Okay? I believe that should now allow you to do question number 5 on the project. I believe. Anyways, let's move on. We're going to take it a step further.
Wait, what?
It's example number 2. Okay, Jeff, remember I'm free helping here. Showing you how to do it. A small sphere of mass 7.0 times 10 to the minus 8 kilograms is suspended in midair above a charged plate. At the point in the air, the electric field is 300 newtons per coulomb. What charge is on the sphere? What charge? We are solving for? Q. What would you like it to be?
C?
Yeah, C is special. Speed of light. And it's a special constant. It's like the number 1 constant. I don't make the rules.
SOL. What's so special about C?
Speed of light. Yes, sir. Okay. You'll note once again that this thing is suspended, which means that the weight force is equal to the electric force. They are balanced. They are balanced. Okay, what do we know? We know the mass, don't we? If you know the mass, you can find the weight force. Fw is equal to mg. Sierra, I heard you say something about a question just a few minutes ago. Did I get to you? No. Are you good now with the calculator? Yeah? Okay. Fw, m times g. So the mass is 7.0 times 10 to the minus 8. And gravity is minus 9.8. And once again, I am calculating. Oh, no, I got it right here. 6.86 times 10 to the minus 7. And that's a weight force, so that is in newtons. And technically that is negative. Which means then that the electric force is going to be positive. 6.86 times 10. Negative goes down, yeah?
And then charge.
Okay, so that is the wave force. I'm asking for the charge on the sphere, Brandon. Let those girls, they gotta listen. They're bothering you.
Yeah.
Sorry, was that out loud?
I don't know.
E equals F over Q. Do we know the electric field strength? Yeah, it's 300. We don't, or 3 times 10 to the 2, right? We don't know the, no, we know the electric force. We do. Fe, yes. 6.86 times 10 to the minus 7. We're solving for Q. Now, as I've said many times, you have to be able to solve these without even thinking. Like, just you know what to do. There's still a few of you that don't know what to do here. You switch them, and you divide. It's automatic. 6.86 times 10 to the minus 7, and you are dividing by 300. And I'll let you try that.
Holy.
2.29 times 10 to the minus 9, and that is in coulombs, right? Coulombs. Now, 2.29 times 10 to the minus 9. Now, it doesn't say what unit to use, it just says what charge on the sphere, but if it asked you, I'll come by and I'll show you. You might have 0.0000229 or something. Yeah, you may have, I think, yep. You know what, if that's the case, just hold on to that number, don't clear it. Just leave it in your calculator, I'll show you the next step, right? Don't clear it. I'll come by and I'll show you how to go to scientific mode, if you want. It's possible. Okay, so now, to go to elementary charges, what do I have to do?
You have to multiply or divide by 1.
See, now here's where people just say, do I multiply or do I divide? And I always answer, set up a ratio, because you can't go wrong. Here's how it works. One elementary charge is how many coulombs? 1.6 times 10 to the minus 19. And if it's asking for it in coulombs, the x goes on the top, and the bottom is coulombs, and so that number is going to be 2.29 times 10 to the minus 9. They're asking for it in Elches.
So it's 2.9 divided by 1.6.
They did, but then while Jeff was talking to you, I said, what if it's asking for it in Elches? So we're now converting it to Elches, Jeff, right? So you know how to do this later. When I say do this, you'll say, you've shown me that, Mr. Bear. I know how to do that. That's what you can say. You won't say, I don't know how to do this. You haven't shown me how to do this. So we're going to cross multiply, and we're going to get 1.6 times 10 to the minus 19x. And all you're doing is, because some people will get it wrong, and I guarantee you, Brett, on the test, there'll be 3 people that say, Mr. Ben, I don't know whether I multiply or divide. And I'll go, too bad, I showed you how to set it up. So if you can't remember, you better learn how to do this. Because I can't help you with that on the test. You have to know. It's like saying to the driver's instructor, I never remember, is it red means go or green means go? I never remember that. They can't tell you that. If you don't know, you're not getting your driver's license.
You should see
That's right. It's just divide. 1.43 times 10 to the 10, but the answer is in Elches. Okay, now I will come by. I understand some of you having difficulties with sign of notation. I'll come by, I'll show you. I'm going to do that on an individual basis though.
I got 0.42, but your calculator display doesn't go far enough and it wouldn't be 0.
Oh yeah, okay. Yeah, it's a good idea to learn how to get your calculator to sign of notation. Yeah.
1.375.
Yeah. You might get, due to rounding, you might get slightly different. I look at the work and I give you the answer. Yeah. Junior. Okay? Go quick, man.
1.8. Right? 1.1865.
I'll come by and I'll show you calculator stuff.
I just noticed that up.
One elementary charge, Millikan said. This is the Millikan.
Like lower down, just right there.
Well, because I'm solving, see I've got 1.6 times 10 to the minus 19x. This is equivalent, Sarah, to 2x equals 10. How do you solve that? Great. That's all I'm doing here. I'm dividing both sides by 1.6 times 10 to the minus 19. That's all I'm doing. Okay, Jeff. What? Sarah's asked me a question. You're distracting her by talking to Jordan.
Sealed calculator. She's trying to change scientific notation. She asked if she could do it, so I let her do it.
Are we good, Jordan? Okay.
Meanwhile, can I pop out and see if I can find the calculator?
I'm going to do the next one. The next one's the hardest one. I told you right from the start you guys need calculators. You got to be here. You got to be here. You got to be on time. You got to calculate. Those are the first three things. All right. Here is the hardest one of the day. Stay with me. I know it's been a long class already. Stay with me. Unfortunately, I left the hardest one for the last. Well, that's what you normally do, right? Okay, so we have now an oil droplet of radius 0.0006 centimeters. Read carefully, slow down, double check, all important. Located in a Millikan apparatus. It is suspended in midair above a 0.3 newtons per coulomb electric field. The density of oil is 800. That is a number you should put on your cheat sheet right now. Those of you that like to have your cheat sheet and you're making it up as you go, put it on there right now. 800 kilograms per cubic meter. That is the density of oil. That is the number we will use on the test. 800. Okay? No.
Or you just say the density of oil is, and then...
I could, but you could also write it on there. It's not that hard. I'm trying to make you into students, right? Independent students. The density of oil is 800. Determine the charge of the droplet in Elches. I'm changing it. Determine the charge of the droplet in Elches. This is basically what Millikan did for every drop. I've simplified a little bit. Okay. We're going to do these same steps. What did we start with? We started with knowing the mass and defining the weight force, right? I don't have the mass here. I got to find the mass. All I've got is the density.
Where are you going to find the density? Because
all I've got is the density and the radius. Now, don't write anything down just yet. Density is equal to mass over volume. What am I trying to find? Mass. If I know density, I'm going to have to know the volume. Okay, so I don't know volume yet. I got to find the volume. These oil droplets are a sphere. In other words, a little teeny tiny ball. A bubble, an oil bubble, that are round. Does anyone just happen to know the volume of a round ball? The formula for a round ball?
Pi r squared.
No, that's the area of a circle. Volume, three-dimensional. It has pi in there.
Height pi r squared.
Pi r what? Pi r cubed?
Yeah.
Close. It's 4/3 pi r cubed. I'm telling you right now. You never learned it. Well, you might have. You might have at some point in your math.
Never seen it.
Well, whatever.
No, I'm passing grade.
No. Everything that I've been teaching, pretty much everything I've been teaching this year has led to this problem.
Wow. That problem makes me want to.
Well, whatever.
Not like the fun one.
I don't, yeah. I'm with you, Brett. Can you come on your name? I'm so. Okay, so here's the formula for volume of a sphere. It is 4/3 pi r cubed. Just write it down. Believe me, I'm right.
Are we going to use that in
We're going to use it right now.
test?
Yeah.
Exam?
Yeah.
Alright.
You got time. 4/3 pi r cubed. So 4/3
You tell that is
volume of a sphere. Volume of a
When
ball.
you say sphere, you see just radius, it could be like a.
He's telling you it's a ball.
It could be like a circumference.
Circumference.
Yeah.
Radius is this.
Yeah.
Circumference is all the way around.
No, but like the circumference is not all baggy and sphere is like you could.
I don't know what you're asking me. Ask me later. Okay. 4/3 pi r cubed. So the radius here now, you'll have to also notice that, guys, you'll have to know, you're really going to have to refocus, you guys. Leo, you'll have to notice that the radius is in centimeters. So you're going to have to take that value of centimeters and do what? No, convert it to meters. So you're going to have to take 0.0006, divide by 100. Okay, Junior, pay attention man. Hard stuff. You need to focus. You're not. If you're laughing, you're not paying attention, because trust me, this ain't funny. So we're going to take that number, we're going to put it in here, 0.000006, and you have to cube it. Because pi is pi. No, it's just pi. 3.14 is an approximation
So you want us
to
to use the pi.
You should use the pi button on your calculator.
Five button.
You will.
If you have a scientific calculator, you'll have one.
Yep.
Meters.
You got to go from centimeters to meters. So, hold your calculator in your left hand if you're right-handed, and right-handed if you're left-handed, and do this. You're going to go 4.
Wait.
Oh yeah. You know what? This number will automatically go. It'll be
4
very small.
divided by 3.
4 divided by 3
Times 3.0.
times pi. No calculator, Brian? You might write me out degrees.
I think I know.
Yeah. 4 divided by 3 times pi times 0.00006. Now the cube button. Listen carefully. Some of you will have an x cubed. Some of you will have an x to the y. Some of you will have a y to the x. That's the button you want. If you have the x to the y, you go 3. If you have x cubed, you just go x cubed. And then you gotta hit equals. You must hit equals. The number one mistake that kids make is they forget to hit equals. And I'll give you the answer, and then I'll come around, sir. I'll give you the answer. Give you the answer. Not times 3. No, not times 3.
9.047.
9.05 times 10 to the 9.05 times 10 to the minus 16 cubic meters. That's just the volume. It's okay, Sarah. You're going to get it. Yeah. Well, that's just step 1. Now, to go from volume, remember trying to find mass, and the formula now is going to be one of the very first ones I taught you, like the first week. D equals M over V. Density is equal to mass over volume. Remember the slope of the line was the density?
Yeah.
The density is how much?
But density and mass is the same thing.
Nope. Density is how heavy it is per volume.
800
Like aluminum is low density, steel is high density. The same volume of steel weighs more than the same volume of aluminum.
Oh,
That's why they make,
Well, yeah, but isn't like a mass something like this? Like,
the mass is how much stuff.
so yeah. And all density.
No. If you've got the same amount of aluminum and the same amount of steel, which one's heavier? Steel. You just said mass and density were the same, but heavier is like the, right? The weight. That's why they make truck beds out of aluminum for fuel economy, right? Yeah. Density is 800. We solved for mass. Put the volume down here, 9.05 times 10 to the minus 16. How do you solve that? You're going to end up multiplying by 800. You're going to multiply, it's going to be a small number, multiplying by 800.
7.238.
Yep, 7.24 times 10 to the minus 13 kilograms. Please notice, please, that I'm breaking these into steps. If you're that one person out there that's still putting everything in a big long line so I can't read, please stop, because these steps are getting more and more and more.
That's 7.24.
I took 800 times that number. 7.24 times 10 to the minus 13 kilograms. Okay, we now have the mass. That is exactly the same as what these questions were like, where we had mass, right? So all I've done is just back up 2 steps. Okay, so now we're going to take that mass, and you're going to go weight force, mass times gravity. The mass being 7.24 times 10 to the minus 13. You're going to multiply by minus 9.8. .09 times 10 to the minus 12. Just multiplying. Negative, thank you. Therefore, the electric force is 7.09 times 10 to the minus 12. We're getting there. What was the actual question? Determine the charge.
Now you put it up.
Now we do, yeah, determine the charge, right? Now we're going to do this step, right here, that we did before.
Is this the
Yep.
time that helps?
Yep. It is.
This is the calculator.
This is easier. Fair way than this.
You could ask someone that knows.
Here's the answers.
I'm sorry, it clearly says in the curriculum, must be able to solve Millikan style questions. That's what this is. Sorry. What's the E value? 0.3. We know FE. It is 7.09 times 10 to the minus 12, and you're going to divide by Q. And so what happens here? The old switcheroo.
Is it positive 12 or negative?
That is a negative 12. Oh, and that's actually common mistake too, right? To be honest, I never actually pressed clear on my calculator. All of the steps are lined up where when you get this number here, you leave that in your calculator and then you just take that and you multiply by 800 and then you multiply by 9.8 and then you take that number and divide by. You never have to retype a number. It just stays in your calculator.
But if you do, you get a different answer, right?
Yeah, you will, especially if you go plus 12 and not negative 12 there. You're going to get a huge different number.
What if you, like, because you rounded it?
I didn't do any, well, I might have done, I'm just following this. I might have done some round. I look for the steps. If you have the steps and your number is reasonably close to that, 5 out of 5. Let me write the answer here, Sarah. Q equals 7.09 times 10 to the minus 12. That would be, no, that's wrong.
Yeah.
I divide by 0.3 and I get 2.36 I have times 10 to the minus 11. And now to get it into Elches, yep, you have to be careful. I really recommend the use of a pencil. You will make mistakes. 2.36 times 10 to the minus 11. And how do I get it into Elches? Could use the ratio thing. Is it multiply or divide? See, I never remember. I don't have to remember. I just set up the ratio. But I like that ratio thing.
Something else.
1 Elch is 1.6 times 10 to the minus 19 coulombs. And so this number goes down below. Put an X on top. And yes, you're right. It's divide. I never remember. I'm trying to model how to solve a problem when you can't remember. I actually do remember because I've done it a gazillion times. Sorry, a Brazilian times. I don't have the number here because I don't have it on my sheet. Could you do that for me? I know it's going to be times 10 to the 8 or 7.
1.75 times 10, times 10, 8.
To the 8. 1.74, Leo? 1.74 times 10 to the 8 Elches. In other words, 1.74 times 10 to the 8 electrons. That's a lot of electrons.
That is a lot.
Yeah, this is the stuff Millikan had to do for every home dropper. Go ahead there. Yeah, and it does sort of teach you a little bit more respect for what he had to do. 100 years ago, too, I might add, right?
Why is it put minus 30 there instead of...
No, that's a decimal.
What is that number? Oh, that's a...
Here?
Yeah. 1.74 times 10.
To the 8.
Minus 11, minus 19.
Yeah.
I believe it's 1.47.
Oh, 1.47? Did I hear, I have dyslexic ears?
I got 4 cents.
I got 4 cents.
Oh, sorry.
What would I do in a case like that with a problem like this? I'd give it to you. I'd give it to you. Did you ever hear the story about how NASA put up put a thing on Mars a few years back, and they had the European Space Agency design some of the parts, okay, for the lander, and someone forgot to tell the people in Europe that the Americans use like feet and pounds and all that kind of stuff. So the Europeans did everything in metric, shipped it over, they installed it, worked good, fired it up, went to Mars, and like, what the heck? Because they didn't have the right units, and just $10 billion downgrade. So yeah, units are important. And the last of the story is you should use metric.
We're kind of